Hello everyone, I am Rushali Chaudhary, lecturer Praveen Patil Polytechnic. Welcome to the Applied Science Chemistry lecture. We are going to learn metallurgy. What is the metallurgy? Extraction of metal. Earlier in the previous lesson we learned what are the alloy. What is the alloy? It is a mixture of metals with another metal or non-metal. It's called as alloy. Why we are doing the alloying process? To improve the hardness, to improve their corrosion resistance, to decrease malleability and ductility, to make it suitable for the engineering, construction, machinery making. We are changing their color, we are changing their chemical reactivity. These are the purposes of making alloy. But alloys are the two types. What are that? Ferrous alloy and a non-ferrous alloy. Alloys are classified into two types: ferrous alloy, non-ferrous alloy. Ferrous, which is having iron as a base metal, is called as ferrous alloy. Non-ferrous alloy, which is having other than iron metal as a base metal, means iron is not a major component, that is called as a non-ferrous alloy. Ferrous alloy, a alloy in which iron is having a main component, are called as a ferrous alloy, like a stainless steel, plain carbon steel, magnetic steel, tool steel. Where iron is the main component, it's called as a ferrous alloy. Non-ferrous alloy, the alloy which do not contain iron as one of the main components, are known as a non-ferrous alloy. Means the alloy which is not having majority component, iron is not there, it is having other than iron components as a major, it's called as a non-ferrous alloy. Like a brass, bronze, which is having a major component is copper. Duralumin, major component is aluminium, are the main examples or the common famous examples of non-ferrous alloy. How the alloying is take place? How we are mixing metal with another metal or non-metal, that is called as a process of preparation of alloy. We are using two processes for making the alloy. First process is called as a fusion. This is a common method used for the preparing alloy. In this fusion process, we are mixing metal with another metal or metal with another non-metal. Here we have to remember first that metal which is having higher melting point is first melted in a crucible, and other components which is having a lower melting point is added in a required quantity. The heavier components are added in the last step, as they are going to settle down at the bottom. To avoid it, we are going to adding heavier components at the end step. The molten mixture is going to stay by using a carbon or the graphite rod. Due to that, they are not going to react. Pure metals are having very high melting points. Therefore, we are using the crucible to melt it, or the refractory materials to melt the metals, and we are using stirrer as a graphite or the carbon rod, because if we use other metal as a stirrer, that other metal itself going to react or added in a alloy. To avoid oxidation of component molten metal, the surface of the molten mass is covered with a charcoal powder. So metal will not contact with the atmosphere, it will not form a metal oxide. So metal surface, molten metal surface is covered with a charcoal powder. Then after molten metal is allowed to cool to get the required alloy. Example, the brass, bronze, these are the alloy prepared by the fusion method. First we will learn brass. What is the brass? It is an alloy of copper and zinc. In this, we are first melting the copper. which is having melting point 1000 degree and 1089 degrees Celsius. So metal which is having a higher melting point, we are melted first. Then after we are adding small quantity or the required quantity of zinc, which is having lower melting point 419, and we are going to stir immediately by using a graphite rod. The whole molten mixture is going to covered by the charcoal powder to avoid oxidation, and we are allowing molten mass after stirring to cool down to get a brass. Similarly, we are preparing the bronze with a copper and tin. Copper having a melting point 1000 degrees, 1089 degree. We are melting first, then we are adding the required quantity of tin, which is having a lower melting point 232 degrees Celsius. And mixture is going to covered with a charcoal powder to avoid oxidation and stir by using a graphite process. Another process is called as a powder metallurgy or the compression technique used for the making alloy. That is called as a compression or the powder metallurgy. In this diagram, you are able to see that we have taken two different powders, two different metal powder. We are allowing to mix in a jar. After mixing, we are doing compacting and sintering. First, we are mixing two metal powders to get a uniform mixture. After that, we are compressed under the high pressure, and then we are doing a sintering. In the compression method, the component metal powder are compressed in a mold and then heated to a temperature just below the melting point of the alloy. This process is having 4 steps. This is done by mechanically, chemically and electrochemical. First, we are going to mixing metal powder in a desired proportions. Then we are doing compacting. The process of converting loose powder into accurately defined dimensions, that is called as a compacting. And this is sintering. It is a process of heating molded articles in a furnace to a temperature below the melting point of the alloy. That is called as a sintering. Due to this, the small tiny particles of metal are firmly welded or joined to one another to give a desired alloy. In the first step, we are converting metal into the metal powder weigh in a suitable proportion. After that, second process, we are mixing this metal powder to get a uniform mixture. After that, we are passing through the compactation. In this, we are going to all particles get stick to each other. After that, we are heating in a suitable furnace. That process, the heating, is called as a sintering. Due to the sintering, small particles of the metal get welded with each other to form a uniform mass. Woods metal. It is obtained by the compression techniques. Woods metal, it is an alloy of bismuth, lead, tin, cadmium powder. So we are taking 4 powders in the particular proportionate and pass through the compression and the sintering to get a woods alloy. Alnico, that is the aluminium, nickel, cobalt and steel. It's prepared by using a compression technique. Ferrous alloy. A alloy which contains iron as a major constituent is called as a ferrous alloy. Plain carbon steel is an example of ferrous alloy. Plain carbon steel are classified into 3 types. What is the steel? It is an alloy of iron with other elements. Includes carbon, nickel and chromium. Steel is stronger than a pure iron, and it can be used for everything from making a utensil to suspension bridges. It is more stronger, more tougher, more corrosion resistance. Therefore, it is widely used for the engineering field. From the making your यूटेंसिल्स, घर के बर्तन से लेके ब्रिज बनाने के लिए हम लोग स्टील यूज करते हैं. There are three types of steel we are going to learn, that is called as a mild steel or the low carbon steel, which is having 0.05 to 0.3% of carbon. Medium carbon 0.3 to 0.6% of carbon. High carbon steel 0.6 to 1.5% of carbon. The various applications of steel are governed by the percentage of carbon present in it, because percentage of carbon decreases or determines steel hardness as well as the durability, ductility. Depending upon carbon percentage, iron ductility, tensile strength, toughness and hardness changes. Therefore, as per the percentage of carbon, their properties as well as the applications are changes. First one is called as a mild or the low carbon steel. Here only 0.05 to 0.3% carbon is there. It is quite tough, highly ductile, weldable, can be magnetized permanently. It resists shocks and impact, difficult to heat treatment and undergoes corrosion quickly. It is used for making a soft wires for making the ropes, bolts, rivet, nails, chains, tubes, plates for the boiler, ship, blades, and for making a powerful magnets. It can be permanently magnetized. Therefore, for making a powerful magnets, we are using a low carbon steel. Medium carbon steel. Carbon content is 0.3 to 0.6 percentage. It is tougher, harder than the steel and shock resistance. Can be welded with the care and can be hardened by the heat treatment. High tensile strength than the mild steel. It is used for the railway engineering, for the railway roads, for making wheels, axles, fish plates, and also for making the machine parts and the gun parts, for making spring, rotors, and various shafts like the armature and the crank shafts. It is mostly used in an industry as it is a shock resistance and welding is possible, having a high tensile strength. High carbon steel 0.5 to 1.5% of carbon. It is a hard and tough, high tensile strength but cannot be welded. It can be hardened by a heat treatment and resistance to wear. Therefore, it is used to produce sharp cutting edges. Application. It is used for making tools like the files, chisels, hammers, punches, wooden working tools and various cutting tools. By seeing this chart, you will understand better. Low carbon steel called as a mild steel. It is almost pure steel, rust easily. It is used for making a car body parts, nuts, bolts, food cans. Medium carbon steel, harder than low carbon. It is used for making nails, screws, metal chains, metal wire. High carbon, it is harder than a carbon steel. It is used for making a cutting tools, for making a knives. We are using the high speed carbon. Thank you for your attention. If you have any doubt, you can mail me. Thank you class for wonderful listening. Thank you so much.